Hi, my name is Constantine. I'm the creator and maintainer of the Norm package. In this talk, I'd like to tell you a little bit about what Norm is. I'd like to advertise it. I'd like to invite contributors to it, invite users for it. I think it's a pretty nice package. So I'd like to highlight what it does well, what it does not so well. I'd also like to talk a little bit about its history, why I had to rewrite it from scratch for version 2, and share some lessons I've learned along the way. So let's start. Okay, so what is Norm? As the title says, it's an ORM, which means it's basically a package that converts nim objects and nim types to SQL rows and vice versa. So basically, this is the gist of it. The way it works right now is that you can define your types as regular nim types, okay? And all I have to do is just inherit from model type. By doing that, you're basically creating a model. And with models, you can do a variety of things. For example, you can create tables for models. You can insert rows into your database. You can select rows and do all kinds of routine tasks that working with SQL actually means. Norm currently supports SQL and PostgreSQL. I don't have plans to add more backends, although there is an open issue that requests MySQL support. I'm not sure I'll ever, get my hands on that. Anyway, currently Norm does the routine part of working with SQL pretty well. So if you're, if you're a web developer, you're creating your typical, REST API server, basically Norm lets you focus on your business logic and not write those SQL queries, which are basically the same for most objects and for most types. However, of course, using any ORM and Norm included does not free you from the responsibility to know SQL and to understand what kind of queries you're running. And to emphasize that, I like to show you how selecting works in Norm. To select a row and convert it into an object, you basically provide a part of SQL query as is. So you really have to understand what you're doing, because this is raw SQL basically. And of course, if you're having a complex business logic that requires optimized queries, no ORM will ever help you, and that includes Norm. The Norm is very good for routine tasks, for repeating tasks, for things like fetch an object by ID, or fetch multiple rows by certain criteria. And it allows you to work with objects, which is more convenient than working with rows. Also, another highlight of how Norm works is that it heavily uses the new fancy syntax available in Nim. It uses dup macro, which allows you to create mutable objects on the fly, and Norm works only with mutable objects. So this is like a sugar that allows you to write short code snippets. Norm supports transactions, of course, and the last thing I wanted to highlight, which is not the least by importance, is that it allows you to totally separate your database configuration from the app. So Norm allows you to read your database config from environment, or from a separate module, or you can actually just create your database connection object explicitly and then just pass it explicitly into the module where you want to use it. So these are some highlights of how Norm works. However, this is not how it always have been. So what you're seeing right now is Norm 2 actually, and I'd like to talk a little bit about Norm 1, how it was implemented and why I had to dump it, actually. So a little bit about history of Norm. Norm started as an example of what I call naming-driven development, which means that I was just talking with my colleague, and I was talking about Nim, and he asked, does Nim have any, Rails-like framework or a decent ORM? And I just said, nothing that I know about, but if I were to create an ORM, I know a kick-ass name for it already. I'd name it Norm because it's name Orm. And he said, yeah, that sounds pretty nice, but I didn't feel I was strong enough a programmer at the moment to tackle such a complex task. So I just, shelved this idea for a year or two. So fast forward, at some point, I had to create a Slack bot that used database connection. So this was the first time I actually implemented this macro called with DB. So what it does, it implicitly injects a database connection into the code block and allows you to call functions on this database in this block. So it's implemented in a really tricky way. The way it is implemented is that those functions like create tables, insert, selects, they are actually declared only within this block. So when I'm opening, when I'm typing with DB and just start typing code blocks, code inside this block, those functions actually do not exist outside this scope. It sounds pretty interesting, and I really like this idea. However, I'm going to show you in a minute why I don't like this idea anymore. So again, this is how Norm 1 looked like. It looked pretty dope, I have to admit. So, I mean, those parts look really nice. Like you can easily read that. It's with DB, all right? We're working with DB. And we're just calling create tables. Everything is clear and pretty much understandable, okay? However, this is the code for it. So just take a look. It's a template. Generating a template. Generating a template again, or even worse, generating a macro, generating a function call. So it's like 3 levels of nestedness, and at a certain point, I just understood that I cannot support this code anymore. So I could not understand what's happening, actually. So at some point in time, I just added those dirty pragmas because it didn't work otherwise, and I still don't really understand what dirty means. So it's a very bad sign that you're adding code you don't understand the purpose of. So of course, this caused a lot of bugs, which I could not really fix because I could not understand where they're happening. Even worse, I was heavily relying on pragmas, which accepted as their argument code blocks. So I had to parse those code blocks inside those pragmas. So I would say that this was a great experience in working with the metaprogramming. So if you're looking for code to see examples of metaprogramming heavily used, I recommend looking through Norm 1 code base, because basically it is all based on macros and parsing the AST and working with the AST, injecting fields inside object definitions and whatnot. Why did I do all this? I mean, why did I have to come up with monstrosities like that? Well, basically, the main reason and the main lesson actually I wanted to share today with you is that I came from Python, and when I started developing Norm, I really had this very Pythonic mindset. And in Python, as you may know, there's only runtime. There's no other time than runtime. So everything happens at runtime. And at runtime, you have all the data you ever need about any type, about any instance, about anything, basically. So you can actually inspect a class. You can inspect an instance of class. You can see all its fields, all their types. You can actually modify those types on the fly. You can inject fields on the fly. You can import modules on the fly. So you can actually do a lot of dynamic things. So I really wanted to do something similar in Nim. And the very early decision that I made in Norm 1, which I think is the main reason I had to rewrite it at the end, was to work with types. And I naively thought that it would be as easy as it is in Python. However, to work with the types in Norm, what you have to understand is that if you want to really, dissect a type definition and learn what a certain type field, what fields does a certain type has, also what their types are, those fields, you have to wrap your type definition into a macro. So like this. And then all you got at this point and compile time, you just have an AST. It's just a bunch of nodes. It's just a huge tree. So you're just starting, traversing across this tree, trying to understand what kind of fields are created there. And that's a really tricky game. I'm going to show you a module I wrote specifically to help me, inspect type definitions. It's very fragile too. That's because you can't really inspect types at compile time, because certain types, like custom types imported from other modules, are not available at this point in time when you're dissecting this particular type. So you really have to have to dance around it a lot. And again, you just end up hard coding your types and just hoping that your users do not use anything outside of built-in types like integers and strings. So to make things even worse, I think, is that I, for some reason, I don't even remember why, but I've just started inserting code into actual type definitions, and code like this formatted additive. So it's a pragma that accepts a code block. This alone is very fragile, because I noticed that certain code blocks don't work, certain code blocks do work. And this just made the entire thing, very easily breakable, so to say. So another disadvantage of working with types, apart from types being very, uninspectable, hard, very hard to inspect in them, was that there is no generic way to instantiate an arbitrary type in Nim. So you can create, you can define a type, object type, with fields, for example, integer and string. So you're pretty good with that. You can instantiate that by just calling the type with empty parens, okay? However, in general, if any type of your field does not have a default value, you cannot instantiate it. So the most obvious example is date time. So date times are in std, but they do not have default values. So if your model has a something like created add field, which is very common, you cannot easily instantiate it anymore. So in Norm 1, I actually, even though I start with an idea that I would work with types and create instances for to haul values from SQL, from databases, I actually had to fall back to instances at the end. So at a certain point, you cannot create a instance yourself. You have to ask the programmer to instantiate a type and give you an instance. What I noticed at this point was that working with instances was much, much easier. And I'm going to return to that thought a bit later when I'll start talking about the changes in Norm 2. So another, I think another mistake that I made in Norm 1 was I really wanted to test what features I could add. So I just started adding all features I could, which led to feature bloat. So here are the pragmas I introduced for Norm 1. You see I've added a pragma to set default values for SQL column, to inject a non-null constraint, and other constraints as well. I really thought that by allowing the programmers to customize and tailor the SQL queries they're going to produce with Norm, I will make the product better. However, this is not the case. So those are not used at all by anyone. And at the same time, they put a certain burden on me as a maintainer of the package. Okay, so this is, I guess that's enough to talk about how bad Norm 1 was. Let's talk about how good Norm 2 is. So at a certain point, I just sat down and started rewriting Norm from scratch. So the decisions I made very early on was, well, first, not to work with types, of course. I really wanted to work with instances this time, and I want to make it as explicit as possible. So in Norm 1, the DB connection was created implicitly by just calling the with DB macro, which had horrible disadvantages. For example, this macro has to take its DB configuration from some place, and this place is here in the macro definition, okay? But that means that I cannot separate the table definition from the with DB usage anymore, because, well, I cannot export this information. It's not a symbol that can be exported. And this macro actually generates this macro. So without this macro, this one isn't even available in the scope. In Norm 2, I wanted to explicitly pass the DB connection as an object in all queries. It made, one could say that the code became a little more wordy. So you have to actually type db dot and then create tables instead of just create tables. However, with the new, fancy Nim syntax called with, you can actually, have pretty much the same interface as previously. In this case, you just type with db in one word and then never call db explicitly inside the block. Now you can just type with space db, and then in this code block basically have the same code. So I think you're not really losing anything. On the other hand, you're having the advantage of having your database connection object given to you explicitly, so you can actually have multiple connections with no problem. In Norm 1, you had to circumvent around that with hacks, like a different macro code with custom DB, which is basically the same thing, but it allows you to call your functions with a different configuration. Switching to instances also solve this problem of inability to instantiate types. Since now I'm explicitly requesting the programmer to instantiate their own types for me, I can, I can now guarantee that if I'm working with an instance, all its fields already exist. All those fields have values. Those values have very well-defined types. I can get those types, very easily at runtime and find a mapping for them, or at compile time actually. So I can know what the correct mapping from this type to the proper SQL type is. This switch from types to models, to instances, allowed me to greatly simplify my code. So if you remember the previous one, which was like 3 levels of nestedness, just compare it to the current one. It's very flat. So it's just procs, okay? It's not macro generating macro anymore. So it's just a procedure, and this is just a procedure. And they're very clearly defined. You can see that this is a procedure working with a DB connection, explicitly defined, and an open array of objects, each of which is a model. Easy peasy. The same goes here. It's an insert proc, works with a single object, which is a model. So just by reading the type definitions, you have the, pretty clear understanding of what's happening inside the function. Another decision, apart from switching from types to instances, was to use It was to actively abstain from bloating the code with features. So now what I have in Pragmas are just 5 Pragmas, and this one was added very recently because there was a feature request for it, an explicit one. So I'm just adding stuff when I'm asked to add stuff, not just because I can add stuff. And those Pragmas, they just had to be here because things would not work without them. I'm going to show you another advantage of simplifying the code base, because I think that's very important. So previously, to add support for a new type, because I was working with ASTs and with nodes. So to actually understand what type a certain field is, I actually had to get this node and inspect this node. And at a certain point, I just had to convert that node to a string and see if that string was actually int, then I think it's an integer. So it's a horrible way to inspect types. And what's even worse is that I had to do all my type conversions in a single template called to, which had just this ugly, huge tree of ifs. So I just, try to, what it does basically, it just tries to understand what a type of value is. And if it's an integer, then we're doing that. If it's in 64, doing that, and so on and so forth. So now, on the contrary, I have this special module called dbtypes, which basically implements all it does. It implements this. It's not a template anymore. It's just a function. So it's a function that takes a certain type and produces an SQL type. So simple as that. So all those functions are one-liners that that produce a well-defined output for a well-defined input. So it's not like a tree of ifs anymore. And the conversion, that goes the other way is also just a bunch of functions. So instead of one huge to template, I have a bunch of small functions, which is generally better for code maintenance, as well as allows for easily, for simpler extensibility. So you could not really extend those definitions. You had to actually modify the core code of the library. If you want to support your custom type now, all you have to do is just implement those functions for it, which is pretty great. Again, the next one, like the great benefit of not calling implicit, not creating implicit database connections in macros, was that I could finally allow the user to define models in one module and use it in another module. I really don't have a nice tutorial on working with norm in web apps, which I'm going to touch a little bit later again, this issue. However, I tried that internally for some project of mine, and it works really nice, especially if you have a web framework like Jester for backend and Karax for frontend. You can actually reuse the same models on backend and frontend, because you're just defining a common module you can import, here and there, and it's just a regular name object. There's nothing special about it. It just inherits from model. Okay. And you could just use, marshalling to JSON to pass the data across the wire. I guess the last thing I would like to mention about the changes, like the big changes in Norm 2, was that I switched from value objects to reference objects. So model is a ref object, and all its children have to be ref objects. This was a big moment for me, because I could not understand. Again, coming from Python, where there is no distinction between value types and reference types, everything is a reference type. So I could not really understand where, when I should use ref types or when I should use value types, what the real difference is. I mean, I wrote the theory a lot, but I could not understand it because I could not, I didn't use it in practice. However, this was the aha moment for me when I was just, I was writing some tests, and this is the moment when I saw that, okay, this is why you need ref types. So I think the thought that actually clicked it for me was that if you're working with resources that physically exist, and you actually, your objects are just, reflections of those physical things, that is a ref object, because there is really no sense in creating different objects for the same SQL row, because it's the same physical resource. You have to refer to it instead of creating, copies of it. Okay, so this is it about norm 2. Just I have like a few minutes more. I like to tell what the future holds for norm. I think what are ways to improve it. So first off, what I really want to add, like a new feature I want to add to norm, is a query constructor. I can repeat that sample again here. To create a select, you actually have to type in SQL query. On one hand, this is nice because it forces you to understand what you're doing. On the other hand, this is not very good because you have to memorize what the table name is and what the field name is, or the column name is. Like conveniently, this is the same as the type name. This is the same as the field name, but this does not mean that it's a good decision. What if you change the field name? You have to update all the queries. If you don't, you'll get runtime errors. So what I really want to, substitute this with is some sort of syntax, which I'm not really sure what should really look like, but it must be something that could be checked at compile time. So I want to construct queries, from types and fields, not with tables and columns. So if you have any ideas of how this could be implemented, please reach out to me on the NIM forum or just create an issue in the repository. Another thing I think needs improvement is the migration story. I have this project called Norman, which is supposed to be a migration manager for Norm. And I have to say that it works. It does work. I mean, I've tested it. However, when I try to use it for a more or less live project, I noticed that the burden of creating migrations and running those migrations, updating them, is actually so high that it really is not worth it. So I just ended up creating a file called initdb.nim, which, a single file containing all my schema and all the demo data I wanted to insert. And I just ran this, file whenever I needed my database set up. So there really was no profit in having a folder migrations, where each migration is isolated from another one, and you can apply them sequentially, and then you can roll back them to a certain degree. It's like Norman can do all those things, but I just could not see how that was valuable. So I'm just inviting experienced web developers, especially those who have experience with like Rails and maybe Django, have worked with in big projects, and share their knowledge about migrations and what's the best way to do them is. So the last thing is, of course, documentation. So I did my best to write this long tutorial, so it should give you a decent understanding how Norm works. However, this is, of course, not enough. So what is missing are video tutorials, blog posts, and the most importantly, examples of web apps which use Norm as their ORM. So I really love to have a tutorial that covers creating a standard REST API with a front end in Carax, and so that they would maybe they would interact via WebSockets or just regular Ajax HTTP calls, whatever. I just really would like to see a tutorial that covers a complete web app with for example, Jester for the backend, Kerex for front end, and Norm for ORM, just to showcase how you can reuse your model definitions, how you can easily, how you can simplify your REST API routes, how you can easily fetch data from the database, how you can easily insert data into the database without actually, worrying about the writing SQL and, validating data from the front end. So if you're using Norm, and you have some spare time, feel free to, again, reach out to me, or just go ahead and create a tutorial, and I'll be happy to add a link to it, to the front page of Norm. Okay, so this is basically it. Thanks for your attention. I'll be happy to answer any questions you might have. Goodbye.